Hello everyone, my name is Fan Yang. I'm the technical marketing engineer for the Cisco CSR 1000V. Today I'm going to talk about how do you connect your direct connect to the transit VPC and how does the CSR in the transit VPC talk to your on-prem network. I will walk you through those two options and I will demonstrate one of the options. If you are not familiar with the transit VPC, you can refer to my previous video on how to build a transit VPC and what are the benefits of doing transit VPC in the AWS cloud. The first, after people build the transit VPC, one of the most asked question is how do they connect back to their on-prem and how do they connect back to their on-prem through AWS Direct Connect. The first option is here, which is also listed on the AWS deployment guide, is you can create a detached VGW. So first, the VGW itself will be doing terminating the direct connect first. If you see at the topology, you will see the VGW will be used to terminate the direct connection with the BGP domain 2 and connect back to your on-prem network. And also, because this is a detached VGW, so you don't attach this VGW to any Amazon VPC, including the transit VPC itself. So it's called detached status. Because it's detached, so the VGW itself will not advertise the route to your on-prem DC of any of your AWS VPC. So the on-prem DC will just use the VGW as another routing point. After you build the VGW to connect to your on-prem, you have to leverage the same automation in the transit VPC. So you can think that VGW is another spoke VGW. So you give it a specific tag, and the Lambda function running in the background will detach that tag and push the configuration to the CSR. So the IPsec tunnel from the CSR to that VGW will be established. And as you can see in the topology, it's going to be BGP domain 1, which is the top part of the BGP. And since the VGW are doing two things, first is doing DX termination to on-prem. It is also doing IPsec encryption back to the CSR in the transit VPC. Since in this case, VGW is doing two things. First is terminating the DX. Second is doing the IPsec. Because VGW will be limited at 1 gig when it's doing IPsec, so actually the total throughput or the bandwidth from the CSR to on-prem ASR will be limited at 1 gig. So the end-to-end bandwidth will be limited at 1 gig, which might not be ideal because customer have 10 gig pipe, some customer. If you are doing 1 gig direct connect, you can use this solution. There's no problem doing this. And actually it can leverage the automation of the Lambda. It's going to be very easy. So I will not demonstrate this option in this case because it's very straightforward. The next one I'm going to demonstrate is called attached VGW. The reason to do attached VGW is customers require 10 gig throughput. So they don't want to be limited by the 1 gig throughput which VGW are doing with IPsec. So in this case, we're going to make a VGW as transparent to the CSR. So basically, you create the same VGW, you use a VGW to terminate the direct connect. As you can see, it's also terminating with the BGP domain 1. And then, since this VGW will be attached to the transit VPC itself, so it will advertise the routes of transit VPC itself to your ASR in the data center. So now your ASR should be able to talk to the CSR directly, and then CSR can build a tunnel to the ASR. If you need encryption, you can use IPsec. If you don't need, since it's already over the direct connect, which is a private dedicated line, so you can just use GRE, and then ASR and the CSR can build another BGP2 domain as I listed here. So in this case, since VGW is only doing the DX termination, it's not doing any IPsec. So the total throughput, end-to-end throughput in this option will give you up to 10 gig. And just to let you know, CSR, each CSR can do up to 5 gig throughput. So 2 CSR will give you up to 10 gig throughput. So you should be able to leverage the whole pipe of your direct connect. But you have to build this solution like manually with the command line so that you cannot leverage the Lambda automation as we provide in the Transit VPC. But I will demonstrate how you can build the setup, and it's very straightforward as well. So here's my demo setup. I have a direct connect. Thanks for Econex providing the link to me. So I have a direct connect. I have my private DC. As you can see, my private DC, I'm also running a CSR to simulate the ASR. Basically, they are running the same software, so the command line is the same. And I have my transit VPC set up. I have 2 spoke VPC connected, so I will use one of the spoke VPC to demonstrate the end-to-end connectivity. I've set up the whole direct connect. The transit VPC setup block is going to be 100 setup block, and then I create a VGW to connect to my DX. So the first step is you create the DX, you create the VGW, you do the DPGP setup as AWS required, and then the VGW in the transit VPC will be advertising the routes to the CSR in the left-hand side. And the second step is you create the loopback IP address on the CSR. The reason I want to create the loopback IP address, it's easier to use because I don't want to use the direct connected IP. Sometimes it's a bit confusing. Then the third step is you should be able to create a tunnel from the CSR on the private DC to the CSR in the transit. And you have to build 2 tunnels because you have 2 CSRs in the transit. And after the tunnel has been built, the CSR should be able to talk to the other CSR on different side, and then they can enable EIGRP over BGP. As you can see, I'm using EIGRP in this case, and in previous slides, I talked about BGP, so it's all up to you what is the LAN side IGP you use or BGP you are using. In this case, I'm just using EIGRP. So that's a very easy setup. So let's go to the demo. So first, let's take a look at my AWS console here. As you can see, I already have a Econex provide direct connect session. So it's a 50 meg, and I already create a virtual interfaces. So basically, you create a connection first, and then you create a virtual interface. And when you create a virtual interface, actually you have to specify what is my virtual private gateway, which is my VGW. I already specified VGW, and your peer IP, and the Amazon IP. So the peer IP actually will be my left CSR IP, and the Amazon peer IP will be the IP I used to establish the BGP. And I also specify 65,000 is my BGP domain used on my data center side, and those are just standard configuration you need to do on the Amazon side. And as you can see, I have the transit VPC running at here, CSR1, CSR2 in the transit VPC. I have another WordPress server running at the spoke. As you can see, the spoke is using 20 subnet. The transit VPC is using 100 setup block. So the setup is already there. Okay, so, and I already create a configuration like a script. So what are the configuration I need to put on each of the CSR and how to build the whole setup. Okay, so as you can see here, the first step is we build the DPGP, and this part is already done before I do the demo, but I will show you the configuration. So if we go, so this is my CSR in the data center side. Let's log into a CSR. If you do show run BGP, you can see the BGP configuration already been set up. I use a password to authenticate with the Amazon side. I enable the failover with BFD, and I'm connecting to the other side with the peer IP 99.0.0.2. And if I do a show IP in the brief, on my side, I'm 99.0.0.1. So I can pin the .2. So which means that show IP BGP neighbor summary show neighbors summary. Yeah, as you can see, my BGP is already up. So that part is just working fine. And I think I can also show IP BGP. Yeah, I can also learn the route. So this is the transit VPC route setup block I learned from the direct connect session. And next stop is the peer IP. So this is all working correctly. The next step is in this slide is to create a create a loopback interface. I copy the config to here. So I'm gonna create a loopback with 99.0.0.9 and /32. I'm gonna copy the config. Okay. And since I create this IP, I need to advertise into the BGP domain. So the CSR on the other side should be able to learn the route. Then I need to configure to advertise in the BGP domain. And then we can go back here. So we finish the step 2. Before we create the tunnel, let's check if the route we advertise on the data center side has been learned from the transit VPC. So if you log into the CSR on the transit VPC, here's my first CSR. If you do show IP route, as you can see, you cannot see the 99.0 subnet, right? That's expected behavior because the route has been advertised to the VGW, not the CSR. The CSR is still using a default route, but you should be able to pin 99.2. Sorry, I think it's 99.9. Let's just wait this timeout, and we can pin it again. Yeah, so you can see we can pin the 99.0.0.9. And if we go back to the AWS console, let's go to the transit VPC. If you take a look at the route table, you can see the 99.0.0.9 is learned from the VGW, which is learned from the remote end of the ASR or on-premise router. So the next step is we need to create a tunnel, which is in step 3. But I want to mention that if you are familiar with the transit VPC design, you should know each spoke VPC or each tunnel on the CSR will be put in a different VRF. And the reason to do that is we can do the segregation on the CSR. You can use route leaking to control which spoke can talk to another spoke VPC. So in order to add another tunnel on the CSR, I suggest you follow the same mechanism to make sure the routing will work in that way. So you need to create another VRF on the CSR and put the tunnel connect back to your ASR to use the CSR. So let's create a VRF first. If we go to the CSR script, let's create a VRF on the CSR1, and we can create it on the CSR2 as well. Create a VRF. Let's just finish the first one, and then we can redo the same configuration to the second one. And now we create a tunnel. So you can see the tunnel source is gigabit 1 on the CSR, which is the gigabit 1. That's the private IP 100 subnet, as you can see. Those tunnel 1 and tunnel 2 are one of the spoke I already connect to. We can cover that later. let's just put the tunnel configuration, and you can see I can put that in the VRF direct connect I just created, and the destination is 99.0.9. Let's put a config here. Okay, and then let's go back to the ASR on the data center side. So let's apply the configuration for tunnel 1 as well. As you can see, the destination is 100 subnet, the source is using Loopback. I'm using Loopback as the source. So let's put here. Okay, so after this, I should do a show IP interface brief. You can see I have a tunnel 1 IP, which is 1.1. The other peer IP is going to be 1.2. Let's take a look at this tunnel IP. Okay, I need to put the IP again because sometimes you put copy the config, the IP will be not configured correctly if there's a VRF config here. So interface tunnel 0, I put IP. Okay, I need to do this first because I create a VRF for definition. Okay, 0 IP address. Okay, so now if I do a show IP interface brief 1.2. Okay, so I can pin the 1.2. So that's the first tunnel we have been built. If you take a look here, from the let's just call this as ASR. And we have a CSR 1, we have CSR 2. Okay, this will be easier. So I already built a tunnel from the ASR to the CSR1. Let's build a tunnel from ASR to CSR2. If we come here, we have to apply the same configuration, and then we have to apply the tunnel as well. So let's, because I forgot one thing on the first on the here. So let's do a show where, and I need to put IPv4 forwarding. So I need to put here. Yeah, I will also put here in case. Okay. So let's apply the configuration here. I'm using a different setup block 2.3. Before it's using 1.3 to connect to the CSR1, 2.3 to connect to CSR2. Also the same loopback as a destination, same IPS, same source. I'll give it 1. Let's log into this one and apply the config and do a show IP interface brief. You can see, okay, my 2.3 is up and it's in a different VRF. I need to apply the same tunnel config on the on-premise CSR, so or ASR in this case. Let's just say it's ASR, and let me apply the config. The destination is gonna be a different IP compared to the first one because that's the CSR2 private IP 100 subnet. Let's apply the config. Do a show IP interface brief. We should be VPC. Okay, I have tunnel 2. If I ping the peer, let me see what is the IP I put here. It's gonna be 2.3. So let's ping 2.3. Okay, I see. Yeah, so let me make it a /24. So let me apply the config. I think I'm using /24 and /30. Let me just reply all the config again. Okay, so I can ping 2.3. I can also ping 1.2. Okay, so which means the tunnel from the ASR to the CSR1 and ASR to the CSR2 in the transit has been up. So after the tunnel is up, you can just enable the BGP, that's the last step, EIGRP over the tunnel. Actually, it's going to be over a GRE tunnel. So this part is also very straightforward. So let's apply the config for the CSR1 first. So what are the config you need? Before we're doing the EIGRP, like what I said, the last steps, you have to apply the same mechanism when you're doing the BGP. You have to enable the VRF, the BGP under the specific VRF we create for the direct connect. And after we enable the EIGRP, we have to let the EIGRP to work with the BGP talking to the VPC, the spoke VPC. So we have to do some EIGRP redistribute, and also we have to do BGP redistribute as well. So the EIGRP config, as you can see, I'm using a route EIGRP1, so I will redistribute the EIGRP routes learned into the BGP to the CSR on the CSR itself. So let me configure this part. It's gonna redistribute EIGRP, even I didn't configure EIGRP yet. You have to do the same thing on the CSR2. Redistribute the EIGRP, and then we can build the EIGRP. Also, you can see I'm also redistribute the BGP routes into the EIGRP because the routes I learned from the spoke is learned from BGP. If I want to pass that route to your ASR, which is in an EIGRP domain, I need to redistribute that route to the EIGRP. That's why there's some redistribution happened here. So let's just copy the config and put on the CSR1. Let's also copy the config here. Copy on the CSR2. So this is just basic routing. And the EIGRP part has been done on my CSR1 and CSR2. So we need to configure the same part on the ASR, data center. So I use the EIGRP1 as well. These are the network that's local to myself. So that's a data center setup block. You can see that way. If you do show IP route, if you do show IP interface brief, you can see gigabit 1 is my data center set block, and gigabit 2 is my direct connected IP. And let's ignore gigabit 3. I don't use in this demo. The tunnel, the loopback is used for the tunnel, and I have 2 tunnels. So I need to make those 2 tunnels in my EIGRP domain so I can talk to the other side to establish the EIGRP label. So let me just copy this config. Okay, now if I do a show EIGRP neighbor, I should be able to see 2 neighbors come up here, and which is built through the tunnel 1 and tunnel 2. So that's basically how the EIGRP works. And if you, I think I also do a show IP route here, so there's no 20 subnet, right? Because the 20 subnet is the remote end. So that's a remote end. So how do we verify if this works is let's add a spoke and see if that route can be passed to your ASR. So I think I already added that spoke already, but let's go to the VPC configuration and find the VGW. That's a spoke A in this case. I already gave it a tag, so it's true. The tunnel has been built up automatically, and you can see the session has been built up. So on my CSR in the transit, if I do a show IP interface brief, you can see those 2 tunnels actually are the tunnels that's connect to a spoke. I have those 2 tunnels on the CSR2 as well. And let's show the route. First, let's get what is the VRF used. Okay, so it's this VRF. If we do show IP route VRF, you can see the 20 subnet has been learned from the remote end, which is the VGW IP. So which means that route has been learned. The direct connect VRF is a show IP route VRF DX. And you can see I can also learn the routes. It's learned from another VRF. So basically this is how the route linking works. So if we go to the CSR or ASR on the data center side, still show IP route. You can see I can also learn 20 subnet. And you can see this is a learned from the EIGRP. It's a DEX, so it's a EIGRP. And the EX, I think it stands for the external, so that's a redistributed routes learned from the another BGP domain. So let's do an end-to-end connectivity test. So that's pin 20.10. So that's my WordPress IP, and let's use pin 1, which is my LAN side or data center side block. You can see the pin works fine. So as you can see, this is very easy. So you let's do a quick recap. So first, you create the eBGP connection from your ASR to the VGW. So the VGW will advertise the route of the transit VPC itself to the ASR, and then the ASR can talk to the CSR directly with the IP I created in step 2, 99.0.0.9. After that, you create the tunnel from the ASR to your CSR and use the loopback IP as a source, and also use the CSR private IP as destination and create the tunnel. After that, if you need IPsec, you can enable IPsec over that tunnel. You can create IPsec tunnel. If you don't use encryption, you can just use GRE tunnel, which I use in my demo. Then you create the EIGRP over that tunnel to enable the dynamic routing protocol, so the CSR can pass all the routes it's learned from the spoke side to the ASR, and ASR will pass all the routes from the LAN side to your CSR as well. So the spoke can also learn the route of your on-premise data center. So I think that's the step I didn't cover it yet. So let's cover that part. If we go to the VPC route table, let's take a look at the spoke route table. We are using spoke A. We take these routes. You can see those routes are learned from the VGW, which is learned from the CSR. So the 10.11.253 are the routes of my on-premise data center. So this is a very easy setup, and you can use, and the benefit of doing this is you can enable the 10 gig throughput with 2 CSR and utilize the whole bandwidth of your direct connect. Thanks for watching.